So our formula for simple interest, interest equals principal times rate times time. We need to remember that this is the interest only, and the other sorts of formulas we're going to use later on in the lesson don't find the interest, they find our final amount, okay? So this just finds the interest. If we need to find the final amount owed, we add the interest to the principal. Everyone okay with that? Yes? Well, let's try an example. I'll put it back in the typing for you. Okay, so let's try a quick example. I'll make it. Who wants to borrow some money? Joe. Okay, Joe borrows $5,400 at a rate of 7.6% per annum. Simple interest. You'll notice that we always say simple interest here. Later on we'll say compound interest. So you need to look for that in the question. Okay. For 4 years, how much does he owe at the end of 4 years? Can you guys answer that, please? Josh, can you just leave like half a page, third of a page, and you can start? Okay, so how do we work it out? What do we do? Good. I equals PRT. What's our, do we know I? No. What's our principal? 5400. Our rate? And our time? 4. Say it again? 1,641.6. Okay, is that our answer? No, that's our interest. So we add on 5400. And Mitchell, what do we get? Perfect. That's our final answer. Anyone have trouble with that at all? No, this is easy. All right, I'm just going to give you one challenging one and then we're going to move on. Okay, so what if we said something like, give me a second, because we asked for the amount of how much he owes back. If it was just interest, that's just how much the bank charges you. But you have to pay back the amount you borrowed plus the interest. So that's why we added on. Okay, all right. What if I said something along the lines of, who wants to borrow money? Me. Jordan. Jordan borrows how much? Just pick an amount. Okay, $10,000 for 3 years. At the end of the 3 years, he paid back $15,545. What was the simple interest rate? Why do you think this simple interest stuff isn't really like that realistic? Yep, and why else? You're more likely to use this more like your parents are going to go, well, I'm going to teach you how to, be good with your finances, so I'm going to charge you interest. Well, my parents did that to me when I was your age. Anything else? Yeah, I know. So it's more likely to be like a practice run. But really, if you're going to borrow $10,000 at the start of 3 years, why in the world would you then be able to pay back $10,000 or $15,000 at the end of 3 years? What would you actually more likely to do if you did this, even if it was with your parents or something? You'd pay it off in installments, okay? So that's why, and in a couple of lessons, we're going to be looking at sort of paying off loans, because this really isn't that realistic. If you can't afford 10 grand 1 year, why would you be able to afford 1.5 times that 3 years later? Maybe. All right. So this time, what are we trying to find? The rate, okay? So once again, we still use our same formula. All right, what number do I put in? What's I? Not Mitchell, someone else. What's I? Good. We have to find the difference between them. And that's the step where most people get wrong. That's the step which most people get wrong. So good work, Nick. Okay? We have to find the difference between those two numbers because that's the interest. Okay? So $5,545 equals excuse me, 10,000 times R times 3. Everyone see to there? So the only tricky bit about this is we need to be able to do some algebra skills. So if we go 10,000 times 3, what's that equal? 30,000. Perfect. Say it again? Percent. Okay, so we would have got an answer which looks like 0. All right, so we've got something like that. What you need to realise is if you write a rate, if we're asking for a rate, we need to write it as a percentage, okay? So our rate equals 18.48%. Now, what's funny about that is, like that seems like a massive interest rate, okay? That's what credit cards are. Credit card you can get from about 12%, but they can get up to about 25% interest, okay? So you guys said, oh, you got ripped off or whatever. If you actually left, if you had a credit card and you put that amount of money on your credit card and you didn't pay anything off, and they actually compound it, so it's even more than that, okay? You would have a massive debt. So beware of credit cards and if you don't pay it off. If you do pay it off, it's all good. We'll talk about credit cards later. All right? Any questions about simple interest? All good with simple interest? All right. Okay. Banks, though, don't use simple interest. What sort of interest do they use? Compound interest. So now we've got to look at compound interest. Let's see if I can do this or not. What's wrong? Oh.
On just clothes and everything. Yeah. And like, because it's interest, she basically just has to pay what she owes and then the interest on top of that.
Yeah.
So she's basically just like,
that would suck. All right. My own fault, I guess. Okay. Compound interest. Okay. In compound interest, the interest is added on to the principal after every compounding period. Now, compounding period could be, what did you just say, Mitchell? We don't really usually go hourly. Daily, weekly, okay, fortnightly, monthly, yearly, half yearly, or will you say biannually? Oh, quarterly, that's the one we're going to forget. Quarterly, biannually. What's biannually mean? Actually, let's say 6 monthly. Yeah, you're right, I'm wrong. 6 monthly, or annually? Okay? So, we need to be out, so I'm saying compounding period. It depends on which compounding period it is. It's when it adds on. Okay? So that interest gets added on, and then the new amount of interest for the next, so if it was monthly, 1 month, interest added on, the next month, the new interest is worked out, added on. Next month, new interest is worked out, added on. So unlike simple interest where it's the same amount every time added on, with compound interest, it's a new amount will be added on each time. Okay? So there is also a formula for this. Now, before we do that, we'll just quickly look at compounding amounts, and we're going to use the word letter N for this. So, if we look at something which is annually, how often is the money going to be added on? Once. So N equals 1, and we're going to need to use this in our formula. Okay? If we said 6 monthly, N equals 2, because twice in a year, the money gets added on. Okay? Quarterly. If it's quarterly, if we add it on every quarter, how many quarters are there in a year? 4. Monthly? We don't really use fortnightly that much, but anyway, we'll use it anyway. Just in case. Fortnightly, N equals 26. Weekly. And daily. Good, we use 365. Yeah, but we just always use 365 anyway. But it always gets brought up, okay? So N equals 365. Yes?
I mean, not to support what Josh just said, but they'll never ask us something about
No.
No.
Okay? So it's always going to be 365. We just use 365 no matter what. Okay? Any questions about that and why we're using that as the compounding periods are annual means 1, etc. Pretty easy? Are people still trying to catch up writing? All right, I'll give you a second. Now, for those of you that haven't done 2CD before, you may not have seen this extensive formula for compound interest before. Okay, we've always, in earlier years, we've always used sort of a more simplified version of this. But if you've done 2CD, of course you have. So our formula for this is, can you remember what it is? You've got it written down. No, you don't? Awesome. All right, that was perfect, but don't draw Batman stuff in the back of your book while you're doing maths. Okay, 1 plus R over N to the power of N times T. All right, so N, what does N mean again? Okay, number of compounding periods. In a year, what's T mean? Time in years. Do we need to label them if they're the same as simple interest? Okay. Time in years. I was expecting you to say no, but anyway, time in years. R equals rate as a decimal. C equals, sorry, P equals principal. What does C equal? I've just written like compounded amount, so your final amount. Okay? Can I just write final amount? In a year. Sorry, my A's look funny. I've tried to change them back, I just can't. Habits. why do you think we divide the rate by the number of compounding periods? So if I said the rate of my loan was 10%, why do you think if it was 6 monthly, I divide it by 2? Yeah? Perfect. The rate is per annum always, okay, in this case. So per annum means per year. If you're going to add on that interest every 6 months, you need to halve the rate for 6 months and then 6 months, okay? Why do you think we times the time by the number of compounding periods? Because that's how many times we're going to be adding it on. So if it's 6 monthly, we go 2 times how many years there are, and that's how many times we're actually going to add on the compounding amounts. Okay, let's try an example. Is everyone okay with their formula? Well, are you okay? All right, let's try an example. Who wants to borrow some money? Max, since you got grumpy before. Max borrows. How much money? 15 grand. For how long?
2 years. 3 years. 3.
For 3 years? Your uni degree is going to cost a lot more than that, just by the way. Pardon? I only paid off my HECS from my uni degree last year.
That's not that much.
That's 10 years ago. 10 years of paying money. I know you're trying to be really nice, but no. I know. Percentage. So the more you earn, the more you pay. Pardon? But then how are you going to live? How are you going to live? You need money to live. The one good thing about HECS at the moment is that it's the best loan you're ever going to get. So HECS has a low interest rate. It just goes up with indexation compared to a bank loan. So if you are going to borrow money, it's best to borrow money off HECS. What did you just say? What did you just say? All right. Max borrows $15,000 for 3 years at a rate of 12.3%. No, let's go with like something like a car loan type thing. Let's go with 8.62%. No. All right. So Max borrows this much at a rate of this, compounding monthly. Monthly. All right. So if we look at this question, what's our principal? 15,000. What's our time? 3. What's our rate? 0.0862. You never round those things, okay? You have to put the whole number in there. What is our compounding period? 12. Okay? If you're getting stuck with any of these sort of questions, write those things out. Go, okay, what are we trying to find? We're trying to find C. Okay? So, using our formula, we can then say C equals 15,000 times 1 plus 0.0862 divided by 12. Why again did I divide it by 12? To make it our monthly rate rather than our yearly rate. Okay? Times, to the power of 3 times 12. So this time we're saying we're not just going to compound it 3 times, not yearly. It's 3 times 12. Okay? Because we're going to compound it 12 for the first year, 12 for the second year, 12 for the third year. And we get an answer. Yep, I'm about to show you that in a sec. Any question? Answer. Going to answer, Jordan? So 785 becomes 7.9 because it's dollars and cents. We always go to the single cent. Are there any questions about that? All right, very quickly, in your ClassPad calculator, almost all of you have the e-activity. And if you don't, you should get it from me at some point. In e-activity, it tells you here if you go further down. Oh, I think I've changed this one a bit. It says simple interest, compound interest. Can everyone go to the compound interest one? You should be able to do this. This shouldn't take me. I shouldn't be having to teach you how to use e-activity because we did it all with trig. Okay, so we should be able to put in P being 1500. Can you guys just make sure that your calculator works with this? Okay, 1500. R equals 0.0862. N equals 3. N equals 12. T equals 3. And then we click on the little dot there next to F. Okay, F is C in this. They've just used F for some reason. Sorry, it's not I didn't make it. Okay, and I think they've just written F for final amount. If you don't know what something actually means, you just click on that little question mark and it tells you F equals future value. Okay? If there's a little question mark, it's because we put information in. All right, and you click solve. Did everybody get the right amount of money? Okay, so to get full marks, you must show all of this working. Okay, the formula with the numbers and your answer. No. So just to highlight a bit, you need to show the one line. So your equation with your numbers, it's the same with trig. You need to show the equation with the numbers in it and then your answer to get full marks. Is everyone okay with that? Any questions? Simple? All right. You guys are hilarious. All right. Your homework is in your booklet. Josh, I need to get you a couple of booklets. All right. He does too. All right, you got a bit of homework to do because you have... Actually, you guys don't have tomorrow. Anyway. No, you don't have any time off tomorrow. Okay, questions on page 9. I'm not going to give you a booklet, just from the booklet, okay? But there's quite a few pages. Page 9, page 10, page 13, 14, and 16. But you got 2 nights to do it in. And you've got 15 minutes now. Okay? 9, 10, 13, 14, 16. You've got last night's to do, which is a page plus your textbook. All right.